This video is all about lines and angles. So our first set of lines are parallel lines. We're going to write down the definition and a symbol. So parallel lines are coplanar lines that do not intersect. And the symbol means is parallel to. Alright, the diagram we're using technically for all three of these, so let's quickly sketch this. We're going to draw seems to be a rectangle. And we're going to make that into a box. Like so, with the point back here being H. So parallel lines would be AE is parallel to BF, or AD is parallel to BC. Right, AD, oops, this one back here should be D. AD is parallel to BC, or AE is parallel to BF. If we were to symbolize that on the graph, we would put little arrows on the line segments that are congruent, or that are parallel. So these two are parallel, these two are parallel, and we differentiate the ones with this one only has one arrow, both of these have two, so that means these two are parallel to each other, these two are parallel to each other. Alright, skew lines are non-coplanar. They are not parallel and do not intersect. For example, AB is a skewed line in comparison to CG. So basically, if you're in 3 dimensions, you're looking at this one is running vertically, this one's running up and down. The two of them are never going to intersect each other. And parallel planes are planes that do not intersect. So plane ABCD is parallel to plane EFGH, meaning the plane up here, that rectangle, is parallel to the rectangle at the bottom. Same thing with ABEF is parallel to DCHG. So the two side planes are parallel to each other as well. Next, we have the definition of a transversal. A transversal is a line that intersects two or more coplanar lines at distinct points. So if we have two parallel lines, we'll call them L and M. They are parallel to each other, and we draw a line through it like such, and we'll call that T. T is going to be the transversal that cuts both L and M. Alright, let's look at an example. So we have a figure right here. It's another rectangular box. We're trying to say which segments are parallel to segment AB. So segment AB is this one right here. They're going to be multiple. We're going to name them. So parallel to segment AB, we could say segment EF is parallel. Same thing with DC is parallel. Part B, which segments are skew to CD? That would be AE over here. Same thing with BF. EH, it's also never going to intersect CD. And FG. All four of them are never going to intersect CD. Alright, part C. What are two pairs of parallel planes? Plane ABCD is parallel to plane EFGH, right? The top and the bottom of the box are parallel. Same thing with plane DCHG is parallel to plane ABEF. The two sides are parallel. There are more pairs than this, but this would be two possible ones. Part D, we're looking at what are two segments that are parallel to plane BCGF. So that back plane there, the back wall of the box, we're looking at what two segments are parallel to that plane. So parallel to that plane would be AD or DH. AD because it would be parallel to the BC line, so that would count, and DH, it's parallel to the CG line, so that also counts. There are more options than that, but we only need two. Alright, and then we're going to look at some angle pairs that are formed by transversals. So we have alternate interior angles. These are non-adjacent interior angles that lie on opposite sides of the transversal. So if we have two parallel lines, and we draw our transversal through it, I'm going to label my angles 1, 2, 3, 4, 5, 6, 7, and 8. Alternate interior angles would be angle 4 and angle 5, or angle 3 and angle 6. Alright, they're on the inside between the two lines, and they're on opposite sides of the transversal. Same side interior angles are interior angles that lie on the same side of the transversal. So if we draw our parallel lines again, put the transversal through it, label our angles again, then angle 4 and angle 6 are same side interior, and angle 3 and angle 5 are same side interior. Corresponding angles. These lie on the same side of the transversal, and in corresponding positions. Meaning if we draw our parallel lines, put a transversal through it, label our angles again. Angle 1 and angle 5 are in the same spot, so those would be considered corresponding angles. Angle 3 and angle 7, 2 and 6, and 4 and 8. Alternate exterior angles are non-adjacent exterior angles that lie on opposite sides of the transversal. So if we have our angles again, alternate exterior angles would be angle 1 and angle 8, and angle 2 and angle 7. And that is all that you need to know at this point about lines and angles.